Why waves? Why? What, was air taken? You know, waves. But think of it this way. About 4.5 billion years ago, give or take a few hundred million, a blurry ball of dust and gas and rock began the long process of settling down into what we now know as Earth. The sun was a baby, so this was a dark and mysterious place. There were no trees, no flowers, no oxygen. There was not a single iPhone. But even before there was water on the Earth, there were giant waves. There were electromagnetic waves and plasma waves and sound waves. There were shock waves, as Dr. Gary Greenberg confirmed, from the many explosions that made our planet's earliest days so lively. And there were, when the Earth began to settle down and solidify, asteroids smacked into it and sent up waves of molten rock thousands of feet high. So why write about waves? Giant waves, I would argue, are the original primordial force. They're a physical reminder of the hidden energies, the unseen energies that power everything. And they're all around us at all times. And the ocean creates these giant waves in a number of different ways. There's several different reasons why a wave becomes this big. One of the most mysterious animals is the rogue wave. And the rogue wave, you hear that phrase a lot, but technically, scientifically speaking, when they talk about rogue waves, what they mean is a wave that's at least 2 times as big as the seas around it, and possibly 3 or even 4 times as big as the seas around it. And for the longest time, these were thought to be as fictional as sea monsters. A lot of lore went around saying, well, this wave came out of nowhere, and scientists did not believe it, because in a lot of ways it didn't make sense. It didn't obey the basic laws of physics, but they do exist. And then, of course, there are tsunamis, the giant of giants. And tsunamis, we've had absolute tragic examples of tsunamis in the past decade. They are waves that have huge, long wavelengths, and they travel at the speed of jets. And when they hit land, of course, they unleash just the most incredible, devastating power imaginable. And then there are giant storm waves. And giant storm waves are caused by big, low-pressure systems that build and are fueled by very heavy winds, and they end up creating huge ocean waves. But what is a giant wave? And when you're in the water, it can seem very relative. I mean, speaking to somebody who was hospitalized by a 5-foot wave while surfing, I think that even small waves are ferocious at times, but for the purposes of defining giant wavehood in my book, I decided to set the basic threshold at the 40-foot wave. So you might be looking at this and thinking, oh, that wave is not so big. It's only as big as a house. But let me tell you, not every 40-foot wave is created equal. Meet Chopu. This is a wave in Tahiti that has the personality of a buzzsaw. And this is Laird Hamilton, Maui homeboy, riding a wave in August of 2000 that many people, including him, thought he was not going to survive. And I think the thing that's most incredible about this wave, and maybe you can kind of tell, is the water here is about 3 feet deep. It's above razor-sharp coral, this reef. And when you start talking to oceanographers and people who know about waves, the words that keep coming up with reference to Chopu are freakish hydraulics. And that phrase, it's not a normal phrase, but I heard it about 10 times, freakish hydraulics. And so you can kind of see the freakish hydraulics here. The wave, when it folds onto itself, it literally drains the water off the reef, so you're below sea level if you're at a certain place to watch it. And the other very strange thing about Chopu is that you can get very close to it. That's me in the turquoise shirt. And there's a channel on the side of the wave. It's just so unusual the way this wave breaks, and you're looking down at the reef. It's literally below you. And you're pretty safe in this spot unless the swell shifts, which it occasionally does. And you know, it takes a very big storm to create a wave like this. And this is another character, inanimate character, that I'm very fond of in this book. I call it the magenta blob. And the magenta blob basically signifies huge storm, giant waves, heavy winds, and when the magenta blob shows up on the weather radar, certain people get very excited. This is Mavericks. This is Garrett McNamara from Oahu, another fantastic big wave surfer, who you can see that Mavericks has the soul of an assassin. Mavericks, in fact, is an assassin. Right south of it, very oddly located off the 18th hole of Pebble Beach Golf Course, is another wave called Ghost Tree. This is Ghost Tree. This surfer is about to have his femur broken into 5 places in the next second. Ghost Tree hardly ever breaks. It almost seems not to exist, you know, sort of like a ghost. And from there, I went further south to a wave off the coast of Ensenada known as Killers. And this is Brad Gerlach on a wave that's about 68 feet tall at Killers. And I did see a wave like that when I was there. And what I learned from watching it was that when a giant wave gets to be above 60 feet tall, it starts to do something different. And different equals terrifying. Most of the times a wave comes along and it breaks, and you think of it that way. When a wave is really big, it marches along as a vertical wall for a while, and at the top of it is just kind of feathering, this white feathering, and it's just the most terrifying thing you could ever imagine, and it made me just realize what it must be like to face one of these waves in a boat. And as with people, as with human characters, you do tend to develop your favorites, and this is my favorite wave, Jaws, about 8 miles east, right from this auditorium, and I'm sure you are all familiar to some extent with Jaws. Jaws is a magnificent wave. It really is. It's like Hokusai's giant wave, and you couldn't possibly come up with a more perfect wave. But of course, incredible violence. And here's Laird again, and I would say that this particular wave is about 80 feet tall. So 80 feet is about the size of we have a water tower here. It's also about the size of an oil rig. This is the Dropner oil rig in the North Sea, and a very important event in the history of giant waves happened at this oil rig on New Year's Day in 1995. And what happened was there were 38-foot seas that day, just sort of usual gnarly weather, and then out of the blue, an 85-foot wave came barreling over the horizon and smacked this oil rig. And the thing was that there was laser measuring device, so they could prove that this weird spike wasn't a mistake, which is a lot of the times what they think. And they would have been willing to write that off too, though. But the wave hit the platform at 85 feet, so it actually did damage and couldn't be denied. And this was so important because for the first time it told science that it's not about if there are rogue waves, but why and how. And this was very important because ships were going missing. This is a ship that was damaged by a wave, but one of the things that really interested me when I started thinking about writing this book was an article I read in the New York Times called The Mystery of the Disappearing Tankers. And these ships disappear at this incredible clip, and nobody really knew why. And a lot of the times, it said in the article, 2 major ships go missing a week. And I couldn't believe this. It's like, these are 1,000-foot, these are not small objects. You know, we can locate atoms, and how are we losing ships every week? So I went to Lloyd's of London, which insures most of the global shipping fleet, to find out what was going on. Lloyd's is a spectacular place. I could write a whole book on Lloyd's. And they have meticulous records going back to the 17th century about shipping. And the figure that I ended up wanting to use in the book and that I felt I could defend, and I think it's kind of a conservative figure, but there's no exact numbers here, was 2 every month. 2 ships every month go missing, usually with all hands on them, gone as well, and that is still a huge amount when you think about it. And some very prominent ships have actually encountered these waves. This is the Queen Elizabeth II, which hit a pair of 100-foot rogue waves in 1995, and in those waves, if you see the bridge windows up there, that means that those waves were about 100 feet tall. So a 100-foot wave 10-story office building, angry 10-story office building. And the Ernest Shackleton, the great polar explorer, when he saw a 100-foot rogue wave, he was crossing the Southern Ocean. He saw this wave, and at first he thought it was clouds in the night sky. And then he realized this was not clouds in the night sky, but it was a 100-foot rogue wave coming right at him. That can't have been a good moment. But he wrote about it later, and he called it a mighty upheaval of the ocean. And I think hitting a 100-foot rogue wave is bad enough, but imagine a 100-foot wave that lasts for 5 minutes. This is a model of the 2004 Indonesian tsunami right near the epicenter of the earthquake that caused it, Banda Aceh on the northwestern tip of Sumatra. What people don't realize about this tsunami is where it hit, the closest part to where it hit, the epicenter, the waves were 100 feet tall. And nobody, of course, has lived to tell about that or bring back photos of that, but they now know that the waves were in fact that tall. And the power of that tsunami, I think, took a lot of people by surprise. It was, of course, here we hear more about tsunamis in Hawaii, but people were like, well, how did a wave kill 250,000 people? And I think as a species, we tend to have a kind of collective amnesia about natural catastrophes. And I think that, maybe that's logical, but not very long ago, these things have happened, and they do happen, not infrequently. This is a woodcut of a huge tsunami that took place in Lisbon in 1755, had an enormous impact on northern Europe, northwestern Africa, razed Lisbon, and we don't often really hear about it. And then Krakatoa, of course, blew in 1883. And it sent another 140-foot tsunami out and just devastated the area around it. And we think of these waves, 100-foot waves or 140-foot tsunamis, as absolutely deadly. But there have been much bigger tsunamis in prehistory. And now they're finding paleogeologists and climatologists are sifting through rubble and finding that there have been very big tsunamis, much bigger, some of them kind of close to here. Volcanic islands all suffer the same fate. They eventually collapse into the ocean, and when they do, they create giant movements of rock. And those landslides and things that move massive amounts of water create the biggest tsunamis of all. So a 100-foot wave is scary enough, but imagine something bigger along the lines of, say, 350 feet. So really what we have here is an air traffic control tower of water. And none of us have seen such a wave or want to. But in case you think that waves this big are just mythical and not real, I want to introduce you to one last character in this book. This is Latoya Bay, Alaska. It's just west on the coast from Sitka. It is my vote for the creepiest, spookiest place on Earth. And the reason why is because on July 9th, 1958, this place kicked up a 1,740-foot wave. 1,740-foot wave. It can eat the Empire State Building for lunch without any trouble. And how do you imagine a wave that big? But we don't actually have to. Some people don't have to imagine a wave that big because 6 people were in this wave. And 4 of them survived it, which is astonishing. And the reason why, I'll go back, is because they could tell exactly how big this wave was, because what happened was a giant earthquake sent a huge amount of debris into the water, kicked up a giant splash, and scalped the edges of the mountains and the trees, everything, even the barnacles were gone from this. So they know they can measure it exactly, and this place has had a history of doing this. It's very lively, and the water's very deep there, 700 feet. So there is no real question that this happened, and of course there are these 4 eyewitness accounts, which are absolutely extraordinary to read. Scientists that I spoke with were uniformly terrified about this, and it is happening, and it is affecting the oceans, and all over the world the waves are rising, they're becoming steeper, there's more wind, there's more intensity and more heat in the system, which leads to more volatile seas. I just want to end with this picture that shows the energy, this is a NOAA picture that shows the energy that came from the Japanese tsunami last March. And it is, it shows you that this is not such a big place. And when you see how this energy of these giant waves wraps around the world, and you see how connected it all is. And I think I just want to close by saying, a lot of the times people ask questions about, well, how can we cope with these rising oceans in these stormier conditions? And I think when it comes to the ocean, we know so little that really what we need to do is approach it with more humility, because as William pointed out, when you look at a 70-foot wave, you realize that you do not have dominion. We know who's in charge here, and it's not us. And yet we know so little about it, so I think we're going to have to be more intelligent, more creative in how we approach it, and more humble. Because as you can see, the oceans connect us, and the waves touch us all, and nobody knows that better than the people of Hawaii. Thank you.